which is known as the radius is perpendicular to the tangent, and subsequently we are going to solve some sums based on the same theorem. So let's begin with the theorem. The statement for the theorem goes in the following way. It says a tangent at any point of a circle is perpendicular to the radius to the point of contact. If we try to decipher this statement, we look at the hint word over here is a circle. As the name of the chapter is circle, let's draw a circle with center O. Now on the circle, we have infinite number of points, but they want us to take any one point. So let's take this point as A. And at this point A, we need to have a tangent. So let's say line L is a tangent to the circle at point A. So A is the point of contact. Now we need to find a special relation of this line L, that's a tangent, with one more special segment, which is the radius. But this segment has to be drawn, or this radius has to be drawn through the point of contact. So A is the point of contact, and O being the center, segment OA is the required radius. Now what is the relation between the tangent and the radius? It said they are perpendicular to each other. That means, children, we can now understand that they intersect at a right angle. So we can now say segment OA is perpendicular to line L, or we can put this in a better way. If I just take a point B anywhere on the tangent, what should be the measure of angle OAB? Angle OAB is going to be 90, and that's what we need to understand. And as for the reason goes, we are not going to write the huge statement. We are going to write a shortcut reason. And the reason is radius is perpendicular to the tangent. So henceforth, for a circle, if you have a tangent, we can draw a radius. And the relation is that they are perpendicular. The reason would be radius is perpendicular to the tangent. Let's solve some sums based on this. Now we have a sum supported with a figure, and in the figure it says that TP and TQ are the two tangents to the circle with center O, so that angle POQ is 110 degree. Find angle PTQ. So we have a circle whose center is given as O, which is very clearly visible to us. Further, PT and TQ are the two tangents. We can see angle POQ is 110 degree. And what we need to do is we need to find angle PTQ. So we can see angle PTQ, and its measure is a question mark for the time being. But if you look at angle PTQ, it definitely belongs to a quadrilateral. Let's consider the quadrilateral OPTQ. Now in this quadrilateral, let's jot down the points which are given to us. Firstly, it's given that angle POQ is 110 degree. So this is given. Further, the remaining three angles, out of which one we need to find. What about the remaining two? Let's look at angle OPT. Now we know for a circle and a tangent, we have a property which says radius is perpendicular to the tangent. So what should be angle OPT? It should be 90 degree. In the same way, even TQ is a tangent. So what about angle OQT? It's again going to be 90 degree. And the reason what we support in the bracket is radius is perpendicular to the tangent. But what we have done, out of the four angles of a quadrilateral, we got three. And we need to find the fourth one. We know this property that sum of all angles of a quadrilateral is 360. Hence, angle POQ plus angle OPT plus angle OQT plus angle PTQ will be equals to 360 degree. Sum of all angles of a quadrilateral is 360. Now what? Let's substitute the values of the angles known to us. That means 110 plus 90 plus 90 plus angle PTQ is equal to 360. The addition of 110, 90 and 90 gives you 290. So when we swap it, we get angle PTQ as 360 minus 290, and the difference is going to be 70 degree. Hence, angle PTQ is equals to 70 degree. Let's go a little further. Now in this sum, we again have the figure. It says that PQ is a tangent to the circle at point P. So P becomes the point of contact. We have a circle to start with whose center is O, and the radius is given as 5 centimeter. So OP has to be 5 centimeter. Further, OQ is given as 12 centimeter. We need to find the length of PQ. It looks so simple, isn't it? Now look at PQ. It belongs to a triangle. Let's consider triangle OPQ. Now in this triangle, we have the information about a tangent. PQ is a tangent. Let's look at angle OPQ. Now if you look at angle OPQ, since we have a tangent, we know that radius is perpendicular to the tangent. So angle OPQ will be 90 degree. We know radius is perpendicular to the tangent. That makes this triangle to be a special triangle, to be a right angle triangle. And in this right angle triangle, we already know the lengths of two sides. To find the length of third side, let us apply the Pythagoras theorem. Hence, OQ square is equals to OP square plus PQ square by the Pythagoras theorem. Now, on substituting, 12 square is equals to 5 square plus PQ square. 12 square is 114. 5 square is 25 plus PQ square. So, 114 minus 25 gives you PQ square. Hence, PQ square should be 119. Now, when we take the square root, PQ becomes root of 119. It's not a perfect square. So, PQ should be root of 119 centimeter, and that's what we need for the sum.